Hello everyone. In this video we're going to look at a ship that is sailing due north, and then at a certain point in its trip it spots a lighthouse which is at a bearing of north 38.6 degrees east, 8.4 kilometers away. And then later on the captain notices that the bearing of the lighthouse from the ship is south 34.5 degrees east, and we want to know how far did the ship travel between the two observations of the lighthouse. All right, so let's go ahead and take a quick look at the situation in a diagram. Notice that we can basically think of the ship at some position going northward, and the first observation is north 38.6 east, so something like that. And then here's the lighthouse, and then later on it keeps traveling north and then spots the lighthouse, this time at south, so the bearing is south and then 34.5 east. So it will look something like so. So we have 34.5 degrees here. So we notice that we have basically a triangle, and we know this side, this is 8.4 kilometers. And we want to know how far did the ship travel between the two observations, so we're trying to find this side of this triangle. So basically, if we go ahead and label these points A, B, and where the lighthouse is located, we'll go ahead and call that C. Let me go ahead and write C here, and remember that's where the lighthouse is. And basically, so we know that this 8.4 will be lowercase b. Here we'll have C, which is what we're looking for, lowercase c, and this side here will be A. So we know that we can actually find the angle C very quickly before we apply the law of sines. We know that C is going to be 180 minus 34.5 degrees minus 38.6 degrees. And if you calculate that quickly, so 180 minus, let's see, 180 minus 34.5 minus 38.6, we get 106.9 for the angle C, degrees of course. Okay, so now finding C is going to be a pretty simple matter, because we know that sine of B over B equals sine of C over C. We chose B, of course, because we know both the angle and the side opposite, so that's the best ratio to use. So here we're going to be solving for C, so let's go ahead and do so algebraically first, then we'll plug in. So we know that C sine B equals B sine C, so we get C equals B sine C over sine B. So now we can substitute the values that we know. So we get 8.4, which is B, times sine of 106.9 degrees, because that is C, divided by sine of 34.5 degrees, because that is B. So if we plug that in carefully, so here what we'll want to do is we'll go ahead and contain the entire numerator in some parentheses. So we get 8.4 sine of 106.9. So we can close those now, and then we're going to divide that by sine of 34.5. And there we have it. So approximately 14.2 kilometers. So that's how far the ship traveled between its two observations. So sometimes they may also ask you, okay, how far away is it from the lighthouse now? So in that case, you can just go ahead and apply the law of sines again. So this time, we'll go ahead and use sine A over A, because A is what we're going to be finding now. We're done with the question asked, but in case they ask you a follow-up question and say, okay, how far is it from the lighthouse now at the time of the second observation, you can just do this. And we know that that's equal to sine B over B. So this time we're solving for A. So let's go ahead and solve for A algebraically first. So we get A sine B equals B sine A. So A equals B sine A over sine B. So now we can substitute. So we have 8.4 sine of A, which is 38.6 degrees. And we divide that by sine of B, which is 34.5 degrees. So now we just have to carefully plug all that in. So we have 8.4. You could copy and paste, but it's a little bit safer just to type it in again. Sine of 38.6. And we divide that by sine of 34.5 degrees. And we get approximately 9.3 kilometers if we round to one decimal place. As always, make sure that you're in degree mode, which we are, so that your answers make sense. All right, so there's another quick application of the law of sines. And that should do it for this video. Be safe until our next video.